We hope that you're ready for our first session. This session will include 3 lectures by excellent experts on the following topic: bioeconomy and raw materials. The credo of the first speaker from Hamburg could be: the development of efficient biorefineries will contribute to the defossilization of polymer production. The man with that belief graduated in energy and environmental engineering from the Technical University of Hamburg. He has worked at the German Biomass Research Center, or DBFZ, since 2008, where he became head of the Separation Technologies and Process Development Working Group in 2011. In 2019, he became deputy head of the Biorefineries department. At the Research Center's Biorefinery lab, he is responsible for establishing the separation processes on a pilot scale. He has also gained experience in techno-economic assessments of biorefineries in many national and international projects. Welcome, Arne Gröngröft from the DBFZ, or German Biomass Research Center, with the lecture Development and Assessment of Biorefinery Processes for the Conversion of Biomass into Polymers. Welcome, Arne Gröngröft.
Yes, hello everybody here in the auditorium and in front of the screens. And thanks for the introduction. Yes, today I am going to introduce a little bit the company that I work for, the Research Center DBFZ, and one project that we are currently working on. Yes. So let me start with a couple of words on the DBFZ. The DBFZ is a non-profit research institute founded in 2008, located in Leipzig, just close to Halle here. And it belongs to the Federal Republic of Germany, represented by the Federal Ministry of Agriculture and Food. We are approximately 260 people in Leipzig doing research on the energetic and integrated material use of biomass. So our aim is to, the topic is how to convert biomass into either energy carriers or materials, chemicals for the industry. We are partly funded directly by the German ministry, and almost half of our funds come from the ministry directly. The other half is coming from projects that we either do in public projects, public funding, or directly for companies. So we also have contract research. And of course, we write scientific papers, but we also do exclusive work for industry players. And our aim, you can see that a little bit depicted in the picture on the right, lower right side, is to move from a fossil-based industry to a circular bio-based industry where we use biomass as a feedstock for the industry, accompanied with renewable energy to come to a circular energy, a circular bioeconomy that does not rely on fossil resources anymore. This is a picture or view on our premises here in Leipzig, or close to here. We're not in Leipzig, we're in Halle, but and we have a couple of different labs there. We have the biorefinery lab, we have a biogas lab, we have a combustion lab, all for biomass, and then we have the research biogas plant and also a larger building where we can do events and also have our offices. And I want to go into what we can do in our labs shortly. In the biorefinery lab, we are dealing with the biomass pretreatment, We can do that with hydrothermal processes. We have reactors where we can heat biomass to up to 350 degree in pressures up to 200 bars to pretreat the biomass and make the ingredients and the compounds of the biomass accessible to further processes. We can do that in reactor sizes between half a liter up to 500 liters. So we are quite flexible. We have already heard that upscaling is an important issue, and we are doing that in this reactor cascade. Furthermore, we can work on the separation of bio-based products. So once you have your products in a slurry or in a solution, you want to get them out and purify them. I will go into that in a second. Then we work on biomass gasifications and also on the synthesis gas processes that follow the gasification. I myself, I am responsible for the separation of bio-based products, therefore I will go a little bit more into this topic. So also here we are dealing with different techniques. For example, for solid-liquid separations, we want to separate the coarse particles in a slurry from the liquids. We can use different machines for that. Then if we have finer particles or finer separation processes, we can use membrane filtrations. And finally, also liquid-liquid separations like extraction, evaporation, or adsorption play an important role. We do that in a pilot scale between 1 and 100 kilograms per hour of throughput. So that is a size where we can also provide samples of these materials. And I think that is also important for the production of base chemicals for the polymer industry, for example. So if you are expert in the conversion of your biomass into a kind of a slurry, kind of an intermediate, you have a fermentation broth, a digestate, a hydrolysate, or something like that, and you want a pure product, then we can maybe help you in purifying your products. A different topic that might be of interest here in this community is our biogas lab, either for making use of the residues of your production process. Biogas is often produced from wet residues of biomass conversion to produce methane. But also in our biogas lab, we work on different processes of for fermentation-based production of bio-based products. So it's not only biogas that we deal with, it's also other products like carboxylic acids that we can produce or the like. Here we have over 60 fermenters with capacities also very differently, ranging from 15 liters to 500 liters. So also here we see this approach of scaling up the processes. Some other topics that we can do is hydrotreatment and calorimetry of biomass. We can, for solid biomass, we can do biomass pelleting and combustion and gasification. I already talked about that. We can even go further in the scale up of biogas plants to our research biogas plant that is almost industrial scale. But this is maybe not so much the topic for today. The desk work that we do might also be interesting here. In the Department of Bioenergy Systems at DBFZ, we work on the sustainable biomass use at national and international level. So in order to do this, we evaluate biomass potentials, we do sustainability assessments, we do market and stakeholder analysis, and also scenario development. And the project that I am going to present here today is a good example of how we approach this. And this is the Green Feed project that we are working on since since more than a year by now. It is a German project funded by the Ministry of Economy in Germany with the aim to develop long-term scenarios for the development of a climate-neutral polymer industry. And we work together with the Wuppertal Institute from Germany and the KIT, Karlsruhe Institute for Technology. And what we're looking into is how does recycling of polymers go together with the production of biopolymers in the future? How is the demand of polymers in the future? How much of this demand can be met by recycling, and how much demand still has to be met by different means, and especially the role of bio-based polymers. So this is a slide showing this topic a bit. So on the left-hand side you see, no, maybe let's start from the right side. So on the right side we have a number of plastic products that are needed and where we have some kind of demand in the market. And these can be provided, if they are provided by biomass, biopolymers, then we have a cascade of how to provide these. We have to turn the biomass first into monomers, then make polymers, and then plastics. And by taking a look into this cascade, we try to identify how much biomass is needed to obtain the required final products. Some of the final products can then be recycled and be turned into plastics again. For some of them, this is not possible, so they are no longer in the cycle. And of course, this leads to a fresh demand of carbon in the polymer industry. The role of DBFZ is the biomass potential analysis in this project, then the identification of biopolymer production pathways, and then we will give this information to Wuppertal Institute, who are working on a model of the polymer production system in the future, and they are modeling demands of biopolymers in 2030 and 2050. And KIT has the role of giving the same information that we provide on the biopolymer production pathways to the recycling pathways, and both our information is integrated into the Wuppertal Institute model. And thus, the future polymer production system is being modeled with as good as possible information. So first results, these are from Wuppertal Institute. They have looked into the demand of polymers, of carbon in the polymer production. And they have taken a look into how much carbon is needed to produce the current polymers in Germany. And they have come up that today approximately 8 million tons of carbon is needed for polymer production in Germany. And if we want to, then they looked into how much of this can be met by recycling, and it is currently today only about 10% of the 8 million tons of carbon that is being needed that can be provided by, or that is being recycled today. So we recycle approximately 0.8 million tons of plastics today in Germany. If in the future we can come up with new recycling systems, chemical recycling of polymers, then we could, if we do a lot of, if we reach very far, then we can come to a point where only 3 million tons are still needed of fresh carbon. So this is the right bar. On the other side, we have looked into the amount of biomass that is available in Germany and that can be used in the future. And we came up with, we looked into how much crop biomass is there, how much wood biomass, and how much biomass residues are in Germany from the current statistics, with different scenarios on how this biomass can be used in the future. We looked into the amounts that are likely to be there. And these show a very broad range. So between 0.5 million tons of carbon and 4.4 million tons of carbon can be supplied in 2030. In 2050, it's 1.2 to 11.6. So why is the amount in our scenarios increasing so much? We have, in these scenarios, the limit of the current energy-related use and, of course, the change of eating habits play a significant role. So we see already that meat production is going down, and if meat production continues to go down, then this will free a lot of biomass to be used in other sectors. Where we are heading in these scenarios is still very open, so it is not clear that we can actually reach these high amounts. I'm very doubtful, but this is the typical scenario work. So now we have the demand side, we have the availability side, and now we're trying to connect the dots and identify the pathways from biomass to biopolymers. And not only in general, but from specific biomasses to specific biopolymers. So we looked into what kind of biomass can be used to produce what kind of polymers. This is a very rough overview of what we have been doing so far. It is not everything set in this map, I would say, but we are connecting the biomass compositions to the type of polymers that are out there. And we will look into the most important of these pathways. Maybe an example for the polylactic acid example, we have started doing so. We have already heard that the demand will increase significantly in the future, and the production is already being built up. So this we see here, the polylactic acid production today is from our numbers about 0.8 million tons, and in 2027 is expected to be almost 3 million tons. When we then look into the production system, how much biomass will be needed for it, then we can see that to produce 2.9 million tons of polylactic acid, about 4.3 million tons of glucose are needed. It's an estimation at the time being, but this is how we work. And then from these numbers, we can see how much raw material of the biomass is needed or can be necessary to produce the glucose. So if we use potatoes, then it's 27 million tons. If we use wheat, then it's 10 million tons. So this is not a sum. We don't need all of the biomass. That's a little bit confusing maybe in this chart. It's either or. But in this way, we can give the numbers to the modelers of Wuppertal Institute, and they will then try to find what can be in the future the demands of specific types of biomass to come up with the biopolymers that are needed in the future. So, coming to my conclusion, even with significantly intensified polymer recycling, large amounts of additional carbon are required. So we estimated here 3 million tons per year for Germany. And these can be met by bio-based plastics, bio-based carbon. Of course, also CO2 utilization can play a significant role and other means, but bio-based is really one of the topics that is very important here. In the scenarios where eating habits change and energy use is limited, biomass, here crops, wood and residues, could supply the need for renewable carbon for the polymer production. If we continue with the current biomass use, the demand cannot be fulfilled. That is the other side. And breaking down the demand for specific polymer types into the resulting demand of specific biomass types is work in progress. I showed you the example that we did for the polylactic acid so far, but this we will do for a number of different polymers. And we are still working on this in the course of the project. So this was the project that I wanted to present. Maybe just a little bit of advertisement in the end. I said that we are having events at our location also. So maybe if you're interested in visiting us also at DBFZ, here are a couple of events that will still be conducted this year. The Biorefinery Tag, Biorefinery Day that we are doing is still open with a call for abstracts. So if anybody has a key enabling technology for the conversion of biomass into bio-based products, feel free to participate. Thanks for your attention.
Thank you. Thank you very much for the exciting lecture. And now welcome my colleague, Dr. Martin Bussmann, on stage.
Hello, everybody.
He is actively supporting me in the Q&A now. So, does anyone have a question from the audience? So you can please use the microphone. Okay, please.
How do you estimate the future use of algae as a possible material for feedstock?
Good question. So as you saw in our biomass availability analysis so far in this project, we looked at the large fractions of the biomass utilization today. That is wood, of course, that is residues of agriculture and wood and so on, and that is crop biomass. We did not include algae so far. I'm not an expert on algae production systems. I would be very eager to see them coming up. I know there are activities. I don't have a good feeling on how much they can really contribute in the future. I'm not the right person to answer this question. I'm sorry.
If there's nobody else, there's somebody, please.
Dr. Patterman.
Talk to the microphone.
Well, thank you very much for a very interesting talk. There is nothing more speculation if you speculate about biomass in Europe. Imperial College has just released a study where all figures are wrong, deadly wrong, that we have much, much more biomass in Europe available, and we're not even thinking about that. My question to you would be, why are you so hesitating in only talking, when you talk about the immediate future, about recycling? Why are you not very strongly also pushing what all the rest in Europe is doing now, without recycling, just put the conversion, the cascade utilization in the forefront, and then have the recycling in parallel? The Bavarian Ministry of Economics, they start to think about to what extent the word recycling should not be replaced by cascade utilization. Because, you know, the recycling by itself is putting so many additional problems like costs, energy, water, quality loss, you know, in particular the textile industry, so that we are very, 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 let me say, cautious, you know, in pushing these recycling ideas so much forward. You know, and I would very strongly urge you to rethink that, and also talk with your colleagues in other European countries. You know, there is a rethinking underway that we must do both, if I may say so, apply both methods in parallel, and not so much fix as we do in Germany on recycling. I would love to hear your opinion on that.
Thank you, Mr. Paterman.
So if I understood correctly, then you are saying that recycling is a good idea, but we still need additional input to the polymer industry. Is that, yeah? And I agree. So we look into the recycling in the project because we think that the amount of polymers that can be recycled, they should be recycled. But we don't see it as the solution, because there is really, so the experts in the project are from Karlsruhe Institute. They are working on the recycling work packages, and they keep telling us that there are so many fractions of polymers that are very, very difficult to recycle, that it is not really the future into like trying to recycle everything. And if we want to do so, then we need clean polymers, because they cannot obtain any compounds that are difficult to recycle, or we have to have like very specific recycling systems for these polymers, and that is really costly. So on the other hand, we need the nice and very, very good characteristics of the polymers, so we still want special polymers. I think that new bio-based polymers should play a very, very significant role. So I agree. Maybe that was not so clear from my talk, but I do agree. The question there, and that is something that we debate a lot with my colleagues also internally, because we look into biomass potentials a lot. And it is true, it is very difficult to come up with true figures on biomass potentials in some areas. So it is still a question, how much biomass can we actually direct to the production of polymers? And the amounts can be quite significant. That is also a message, I think. And then the policy right now is focusing only, or very much on using only residues and so on. So crop biomass is hardly accepted to be converted into polymers, I would say, at least in Germany. I'm skeptical if that's the correct way. I think it is a huge potential to also use some of the crops cautiously, but I think it is still a way to go.
Thank you so much for answering our questions, and thank you for the great presentation, Arne Gröngröft from the DBFZ. Thank you so much.